Hi everybody, welcome to our Unit 1 review for limits and continuity. Each day we'll be doing a different chapter or unit in preparation for the AP exam. And as you know, the exam is only free response questions. So once we do our chapter reviews, we will get into free response practice. So today's lesson will be divided into 4 skills. The first skill is about limits. How do we find limits? Good news, it's super easy. All you gotta do is plug it in. By the way, I encourage you to pause the video and copy these notes down. They'll be very helpful for the next few problems. So number 1 says, find the limit as x approaches 2. Simply plug it in. We'll have 3 options. Either, in situation 1, we'll have 0 over monkey, 0 over 1, 0 over -3. In that case, the answer is just 0. In the second scenario, we'll get a number over 0. And as you know, 0 can't be in the denominator. The answer would simply be does not exist. However, sometimes we'll get something in this third scenario, 0 divided by 0, which is called indeterminate form. In that case, we have 2 options, and we'll address them in our next problem. So let's begin just by plugging this in. So it's asking for the limit as x approaches 2. I'm just going to plug in 2. That's 2 times 2 squared is 4, minus 3 times 2 is 6, minus 2, all over 3 times 2 squared is 4, minus 2 times 2 is 4, minus 8. Next up, that'll give me 8, minus 6 minus 2 is 8. And in the denominator, I have 12. Minus 4 minus 8 is minus 12. So indeed, I get 0 over 0. Now this step is key. You have to show the 0 over 0, put a check mark to indicate that yes, we're going to scenario 3 here. Okay, so we have 2 options. In the first case, we can apply L'Hopital's rule. So as a reminder, here's how L'Hopital's works. You simply take the derivative of the top, which would be, so let's write our limit. The derivative of the top would be 4x minus 3. And we take the derivative of the bottom, which would be 6x minus 2. We copy down the limit, so we can now plug it in. So in this case, plugging in 2 to the numerator, I get 8 minus 3 over 12 minus 2. My final answer is 5 over 10, or 1/2. And so that's one thing I can do. I can use L'Hopital's rule, take the derivative of the top, the derivative of the bottom, and then plug in my limit. Now, the second option is, especially if you notice you have factorable polynomials, we can simply factor and see if anything cancels. So in this case, I'll factor the numerator. I need 2 numbers that multiply to -4, but add to -3. I'm dividing by the number in front. And I find that I can rewrite this expression as x minus 2, 2x plus 1. Now let's factor the denominator. 3 times -8 is -24. Has to add to -2. That's going to be -6 and 4. Dividing by the 3. And simplifying my fraction, I get x minus 2 and then 3x plus 4. So notice that I have a common factor on top and bottom. I'll cancel x minus 2. And this actually eliminates my problem. Now I can just plug in 2 into the remaining expression. So 2 times 2 is 4 plus 1 is 5 over, plugging in 2 into the bottom now. 3 times 2 is 6. Plus 4 is 10, and indeed, I get the same answer, 1/2. So in this case, we could have factored, but probably the faster way to do it would be to simply apply L'Hopital's. It's up to you. But the key step is you have to get this 0 over 0 before doing either of these methods. All right, let's highlight our answers and move on. Okay, number 2, again, another limit problem. This time we're dealing with trigonometric functions. No big deal. We'll just plug it in. So directly plugging in, I get cosine of pi all over 2 times pi squared. Let's see what cosine pi is. Pi is over here. It's 180 degrees. That point is negative 1, 0. Cosine is x over r. So cosine of pi is negative 1 over 1, which leaves me with negative 3 when I multiply, all over 2 pi squared. Notice I didn't get 0 anywhere, not in the top, not in the bottom, and certainly not in both situations. So we're done. We found the limit just by plugging it in. So if you plug in the limit and you just get a number, that's your answer. You only have to worry when you get zeros. Let's try this. Why don't you try pausing the video and working ahead of me. So step 1, we'll always start by just plugging it in, right? Equals. Negative 2 squared is 4. 4 times negative 2 is negative 8 minus 3. All over. Negative 2 squared gives me 4 minus 4. So let's see. In the numerator, I get 12 minus 8, which is 4 minus, so this became 4 minus 3, all over 0. Ooh, this one's a little tricky. I got 1 over 0, so the answer is does not exist. So if you're rushing, you might be tempted to just kind of say, okay, it's going to be 0 over 0 and then move on. But in this case, it was actually 1 over 0. You just have to be careful with your algebra. Make sure you're actually getting 0 over 0 before moving on to L'Hopital's or any other method. Okay, try this problem yourself. Pause the video here, give it a shot. The answer you should have got was 0. All right, let's try number 5. So it's starting to look a little trickier, but as always, we'll simply plug it in, see what happens. Plugging in 0, I get 3 times e to the 0. Anything to the 0 is just 1. Minus 4 times cosine of 0 plus 1. All over 2 sine of 0 plus. Now this, when I plug in 0, will just collapse. And when I plug in 0 into the final term, that will also collapse. So that's what we've got. Now, you could go and draw the xy coordinates for 0 and figure out sine and cosine, but I just want you to memorize that cosine of 0 is 1 and sine of 0 is 0. If you can commit those to memory, it will make your math a lot faster. So cosine of 0 is 1. Sine of 0 is 0. So in my numerator now, I have 3 minus 4 times 1, which is 4, plus 1, all over 2 times 0, which gives me 0 over 0. So what can we do? We can apply L'Hopital's rule. Convince yourself that in this case it doesn't make sense to factor and cancel. These are not polynomials, right? We have trig expressions, we have exponentials, so we're going to go ahead and just apply L'Hopital's. The numerator becomes 3e to the x. That's the derivative of e to the x. Minus 4. The derivative of cosine is negative sine, so I'm changing my sign there, and the constant disappears. The derivative of the bottom now is 2 cosine x plus 6x minus 5. And see if you can figure out what I've forgotten to write down. Yeah, I didn't bring down my limit. I have to bring down the limit every single step until I actually plug it in. Now that we've taken the derivatives, we can plug it in. That's 3e to the 0 plus 4 sine 0 over 2 cos 0 plus. Now that will just collapse, and then we have a minus 5 at the end. Let's see where this takes us. E to the 0 is just 1, so 1 times 3 is 3. Sine of 0 is 0, so this guy collapses. Cosine of 0 is 1, so we get 2 times 1, which is 2, minus 5. My numerator is now 3, the denominator is negative 3, so my final answer is negative 1. We got a number, so we're done. Let's say we had actually gotten 0 over 0 again. Okay, it could happen. So we got 0 over 0 the first time, then we applied L'Hopital's, and if we got 0 over 0 again, we would simply take the derivative again. We would use L'Hopital twice. And we keep just repeating that process until we get a number, or does not exist, or 0. All right, let's do number 6. Actually, this one you're going to try it yourself. So we had to apply L'Hopital's here. We got 0 over 0, so we're going to plug in 0. We get 2e to the 0, which is 2, plus 5 sine of 0, which is 0, all over 4 times 0 is 0, plus 3 minus 2 cosine 0. Cosine 0 is 1, so we just got minus 2. Numerator is 2, and in the denominator, 3 minus 2 is 1. Our final answer for this problem, we should have got 2. Okay, just a couple more. Try this problem with me. So when we plug it directly in, we'll get ln of 5 minus 2, which is 3, minus ln 3, all over 2 times 5 squared minus 9 times 5 minus 5. The numerator immediately collapses. That's clear. 5 squared is 25 times 2, that's 50, minus 45 minus 5, which, doing the math, gives me 0 over 0. So what shall we do? Again, factoring doesn't work. We have logs involved, so our only option here is to apply L'Hopital's. Don't forget to write the limit first. So the limit as x approaches 5 of this function is the same as the limit as x approaches 5 of, let's take the derivative on top. Now the derivative of natural log monkey is 1 over monkey times the derivative of the inside expression, which is just 1, minus. Now natural log 3 is just a constant. If you plug it into your calculator, you're just going to get a number. So the derivative of any constant is 0. That guy will collapse. All over 4x minus 9. So let's pretty this up a little bit. We have 1 over x minus 2 all over 4x minus 9. I notice a complex fraction, so immediately I'll put the denominator over 1. And this helps me keep track that I need to flip this eventually and multiply by the reciprocal of the denominator. If you don't put the over 1, it sometimes gets a little confusing, like which is the numerator, which is the denominator, what's going on. So anytime you have a complex fraction, just immediately put the remaining guy over 1, make it easier. Okay, let's plug this in. Notice I haven't plugged anything in yet, so my limit expression should still be there. Okay, so we get 1 over 5 minus 2 is 3, all over 4 times 5 is 20, minus 9 is 11 over 1. Now I'm going to multiply by the reciprocal. So that's 1/3 times 1 over 11. My final answer is 1/33. So we did have to apply L'Hopital's once here. See if you can do this one on your own. 0 over 0, L'Hopital's kicks in. So rewriting our limit, let's take the derivative of the numerator, keeping in mind we have a chain rule to apply. So the derivative of 3 sine monkey is 3 cosine monkey times the derivative of the inside guy times 2, all over 4. Let's make this a little prettier. That 2 multiplies in front with that 3. I will not forget my limit expression. And now we can try plugging in 0. So I get 6 cosine of 0 all over 4. And cosine 0 we know is just 1, so I get 6 over 4, or 3/2 once we simplify. Ta-da! And that's all there is to know about finding limits. Once again, you just plug it in. If you get 0 over monkey, it's 0. 0 on the denominator does not exist. And then 0 over 0, you have a couple options. Either you can factor, if you have polynomials that can factor, or you can apply L'Hopital's rule. Take the derivative of the top, take the derivative of the bottom, and then plug in the limit.